afternoon, everyone.
Good afternoon, ma'am.
So today we'll be looking into the experiment 10, which is demonstrate the use of Numpy arrays in Python. So let us get started. So the first thing that you need to do is I hope everybody can see the screen.
Yes,
Somebody confirm? Okay, fine. Fine, good. Okay, so the first thing that you need to do is you need to import the Numpy package. So wherein I'm creating an alias for it, which is np. So then I am creating an array. So the name of the array is arr. And then, so this is how I need to create. So np.array and then followed by the dimensions that you wanted. So say I want 2 dimensions. 1, 2, 3. This is the first dimension. And then I do have another dimension, which is I can say 7, 8, and 9. So you can see that this is the first row. 1, 2, 3 is the first row. 7, 8, 9 is the second row. Okay. So each and every dimension, individual row is considered to be one-dimensional array. So this is how I created an array. In the similar way, you can also create a single dimension and also 3 dimension and so on. So let me print this and show you. So I simply need to call it by the name. So the name of the array is arr. I am just putting it in the print statement, which is arr. Let me run this and show you. Okay, so this is np. Okay, so this is your matrix. Okay, so the 2-dimensional array. As I said, this is the first row and this is the second row. Okay, fine. So this is how you can create an array by using the Numpy module. So now let us look into some of the attributes. So which is the type attribute. So if you are applying the type attribute, so I'm just applying the type attribute over here. So type arr, so which will give the type of the array. So what is the type of the array? So it is numpy.ndArray. So this is the class that this array belongs to. So let us now look into what are the dimension of this. So there is an attribute which is called as ndim. So I'll be using this ndim attribute to find out the dimension of arr. Arr is the name of the array. You can give whatever name you want here. Okay, so it can be A or it can be B or whatever. Okay, so arr is not a keyword. Okay, so some of you might think that arr is a keyword. No, it's a valid identifier. That's it. Okay, so I have given 2. I got the result as 2 because I have given a 2-dimensional array here. So it is telling me the dimension of A is 2. Okay, right. So in the similar way, I can also use the shape attribute. So to find out the shape of this particular array. So I'm saying a dot shape. Okay, fine. So let me run this and show you. So you can see that it is giving me the rows and columns. So there are 2 rows. As I already told you, this is the first row and this is the second row. And how many elements are there in individual rows? 3 elements are there. So 2 rows with 3 columns. Okay, right. So that's what you will be getting in shape. Now let us look into another attribute, which is the size attribute. So I'm saying a dot size. Okay, so let us click on the run button and see what I'll get. So I'm getting 6. The total number of elements in the array are 6. So size gives me the number of elements in the array. In the similar way, I can also find out what are the type of elements inside the array, like what is the data type of the elements in the array. For that, I need to use the attribute which is dtype. So the dtype will tell me what is the type. Okay, so you can see that the type is of integers. All the elements inside the array A are all integers. Okay, so I got I can see that with the help of dtype. So let me now create a floating type of array over here. So I'll be taking the same array, but I'm adding one more argument over here, which is dtype is equal to. So I just need to mention the type that I want, the elements type that I want. I want all these elements to be of floating type. So let me show you. Now I have, even though here you can see that they are all integers, but I made them as floating. Okay, so all the elements are of float type. So you can see when I printed the elements type with A, element types of A array, so you can see that I got an answer which is float 64. Okay, so likewise I can give complex or anything. I can give over here int, complex, float, and all that I can give. And so if you just want to see the output of it, so I'm simply putting an A in the print statement. So you can see I got 1 dot, 2 dot, and all that, which indicates that it is a floating type. Okay, right. So now let us look into another part, like wherein I can give a tuple and convert it into an array. Okay, so I am giving a tuple over here. So say the elements inside the tuple are 1, 2, 3, and then when I print A, you will be able to see that it will be in the format of an array over here. Okay. So the square brackets you can see, which indicates that it is an array. So let us look into another operation wherein I'm going to create an array which is of 2 by 2 or 4 by 4 or anything. Okay, with all zeros in it. So for that I can say np dot zeros. So in place of array I am putting zeros. Okay, and I need to mention the dimension of the array. Okay, so the dimension of the array that I want to create is, say I want to create 2 by 2. So I am giving a 2 by 2 and then a. Okay, so you can see that a 2 by 2 array is created with all the elements in it are 0. In the similar way, I can also change this. Okay, so 3 by 2, whatever. Okay, so the dimension is your choice, and wherein all the elements in it will be initially 0. Okay, so this can be the initial array, and later on, like based on your application, you can start adding certain things into the array. And the next one is full, np full. So wherein I said np full, and I'm creating an array which is 3 comma 3 or whatever. Okay, right? And then I said comma, and then 6 comma, then d type is equal to, so then I'm saying complex. Okay, okay, so np dot full. Okay, girls, I think you can see it over here that a 3 by 3 array is created, and all the elements in it are of 6 value is given for all the elements. In the previous case, I said like np dot zeros, right, wherein all the elements are zeros. Here, I'm giving a default value for the elements, and the default value for the elements is 6. Oh, I can also make it 7 or anything. Okay, so make it 5. So you will be seeing all 5s over here. Okay, so the default value is 5, and I said the D type is complex. Okay, so you can see that there is an imaginary and the real part over here in each and every element. Or else I can also make it as an int. Okay, so all the elements will be of int type. Okay, like this. So you can also create an array with a single element in all the positions of the array. So this is regarding the full. Next we'll see what is random. Okay, what is random function? So np dot random dot random, and the size of the array that I want to create is 3 by 3. So I said 3 comma 3, and let us look into what will be the answer. So you can see that I got all random numbers. Okay, so all random numbers are given here. So there is no sequence or nothing. So I just got random numbers over here, and the matrix is the array is of 2-dimensional array, and the size of the array is 3 by 3. Okay, so you can also alter this accordingly and create an array with the random elements in it. So now let us look into another function, which is arrange. Okay, so you all already have seen the range function, which we have looked into while studying the for loop. Now we are looking into arrange. Okay, so range is where you'll be having a starting element and an ending element. So that is different from arrange over here. Okay, right. So there are three arguments inside this arrange. So the first one is 0. So 0 comma, then I said 30 comma 5. Okay, so I'll show you the output of this. So you can see that we want to create an array from 0 to 30. The elements in the array should be from 0 to 30, and wherein this is the step. Okay, so 5 is the step over here. So the first element will be 0 after five steps. Okay, so 5 will be the next element, and after 5 steps 10 will be the next element. Okay, so you can create an array in this manner by using arrange. Okay, so wherein the first one is the beginning number that need to be included in the array, and 30 is the last number that need to be in the array, and then this is the step. Okay, right. And let us look into another function, which is Linspace function. So Linspace. Okay, so this is taking in so 0 comma 5, and then I'll give 10 over here, and let me execute this and show you so you'll understand it better. So I said like 0 to 5, right? So I want 10 numbers if from between 0 to 5. Okay, I want 10 numbers. So the first number is 0 point, and the second number is 0.55. So there is no you can see that there is no relation between one number and the other number. So there is no step like thing over here, but I'll be getting 10 numbers between 0 to 5. Okay, so that's what is the Linspace. It is different from arrange. Arrange and Linspace are not same. In the arrange, what we have done is we are also mentioning the step. Okay, so how much it need to increment, or one step or two step or three step, that is there. But here you cannot control the numbers. Okay, like with the step and all that, randomly 10 numbers will be generated in between from 0 to 5. Okay, you can also say 20 numbers. Based on that, the numbers will be created. So this is regarding the Linspace. That's the difference between Linspace and arrange. Okay, and the next one is how to create a array. We'll take a three-dimensional array. Okay, we'll create a three-dimensional array by taking in on a two-dimensional array. So np dot array. So I said I'll be taking a two-dimensional array, which is 3 by 4. So I'm having this is my first dimension. I'll be taking I said 3 by 4, right? Okay, so 4 elements are there, and then comma. Then this is my second dimension. Second dimension is 5, 6, 7, and 8. Okay, so my third dimension is 9, 10, 11, and 12. I'm giving you in sequence so that you will know like how many elements are there. So 3 by 4, right? So there will be 12 elements. So there are 12 elements over here. So this is a two-dimensional array, which is a matrix. So now let us convert this two-dimensional array into a three-dimensional array. So I'll be using the method which is called as reshape, and I'll be after creating a new array, I'll be putting it in another array which is n. So n is considered to be a new array. So which is a dot. So the array that I'm going to consider to reshape is a. The name of the array is a. So a dot reshape, and then I'm mentioning that I need two matrices which will be of size 2, 3. Okay, so the first one is how many matrices I want. So how many arrays I want. So I want 2 arrays, and each and every array will be of 2 by 3 size. Meaning that 2 by 3 means 6, right? So I'm having I want 2 arrays. So 6 into 2, which is 12. So these elements will be sufficient to create that two matrices, 2 by 3 matrices, which will be 2 here. Okay, right. So let me print this and show you. You'll understand. So this is, I'll be printing n and show you. So you can see that, as I already told you, this first two is that I need two-dimensional arrays. So this is the first two-dimensional array, and this is the second two-dimensional array. Okay, so this first represents that, and the next two represents that. Inside each and every two-dimensional array, how many rows are there? So here you can see this is the first row and this is the second row, and the third attribute represents the columns in each and every dimensional array. So how many columns are there in the first 2D array? So I have 3 columns. In the second 2D array, I have again 3 columns. So this represents that. I hope this is clear. Reshape is clear, right, to everyone? Yes?
Yes, ma'am.
I'll also print A and show you. Okay, A is as it is. Okay, so there is no change that happens into A. You can reshape it and put it in another array. Okay, but the original array will be as it is. So let me show you another method, which is called as flatten method. I am taking a a two-dimensional array over here, and then I'll be applying this flatten method over here. So f is equal to flatten. So everything comes into one single dimension. Okay, right. So what you want to flatten? I want to flatten a dot flatten. Okay, right. And then let me print f first, and then I'll be printing a. So let us look into the output. You can see that all the elements now became a single dimensional array. Okay, so this is one dimensional array, and A is as it is. Okay, so as you just taken A and flatten it and put it in another array, A original array is as it is. There is no change in the original array. But what happened is all these dimensions became a single dimension. Okay, right. So this is a 3 by 4 matrix, right? So this is a 3 by 4 matrix. Now it became only one dimension matrix, one dimension. That's it, a single linear array it became. So that is the functionality of flatten. So you can use all these methods wherever needed in your applications accordingly. So this is the end of your 10th experiment. So all the first 10 experiments are over. So I hope Numpy is clear to everyone.
Yes,
All the
ma'am.
methods and how to create. Okay. Now let us move on to create the case studies. Let us look into the case studies. Let me show you the list of experiments. Now coming on to the next part of your lab syllabus. We have 5 case studies. The first one is case study on loops. The second one is case study on functions. Third one is case study on modules and lists, and then classes. Okay, fine. 5 case studies are there, but individually they are some case studies do have a lot of things to do. Let us look into the first case study on loops. A perfect number is a number for which the number of its proper divisors is exactly equal to the number. So here the question is like you have to find out the perfect numbers from a given range. So I'll be giving n, for example. So say I have given 100 for n. So you need to find out what are the perfect numbers from 1 to 10. Okay, so in between 1 and 10, 1 and 100. Okay, so say I gave n to be 100. So from 1 to 100, how many perfect numbers are there? How many deficient numbers are there? And how many abundant numbers are there? You need to find out. So what is a perfect number? Perfect number means that the summation of its divisors is equal to the number itself. So so then you call that as a perfect number. Example of a perfect number is given here, which is 28. So the divisors of 28 are 1 and 2, 4 and 7 and 14. So when you sum up 1 plus 2 plus 4 plus 7 plus 14, which will sum up, add up to the number itself, which is 28. When you have such kind of result, then you call 28 to be a perfect number. If the sum is less than the number itself, then you call that as deficient number. And when the sum is greater than the number itself, then you call that as an abundant number. Here, what exactly the program, the case study is asking you to write down. The first thing is you need to write a program for any number n. Say, for example, I have given 100 for n. So you need to find out the sum of all perfect numbers, and meaning that saying that there are 3 perfect numbers in between the range 1 and 100, like that. Okay. So the sum of all deficient numbers, like there are 20 deficient numbers or 30 deficient numbers, that kind of sum you need to give, count you need to give. So don't get confused with the sum of all deficient numbers and all that. And count of all the abundant numbers separately. So you need to give the count of perfect numbers, deficient numbers, and abundant numbers in between a specific range. And the range n will be given by the user. You need to read from the user n, and based on that you need to work out. And not only this, you need to print all the perfect numbers along with its sum, and then the deficient numbers along with its sum, and the abundant number along with its sum. Okay, so that is the case study. So I hope the case study is clear to all of you. Is the case study
Yes.
clear? So let me
Yes.
get to the yeah. So with this, let me get to the terminal and let us start working on it.
Yes, ma'am.
Okay, so I have created a file which is called as per1.py. So let me just put the concept over here so that you'll understand it. So the concept, I hope everybody understood what is a perfect number. Is it clear or not?
Yes, ma'am.
Everyone understood, right? What is a perfect number? Yes. Uh, so first thing that you need to do is you need to read in the number n, and from that we'll start working towards finding out the perfect number. So first I'll be reading in n from the user. So I said n is equal to so which is an integer number. Um, So here, see, I'll just explain it once again to you. So from 1 till n, okay? So you need to find out what is a deficient number. For example, I'll be taking from number 1. So I'll be telling 1 is deficient or not. And then I'll say if it is deficient, I'll say 1 is deficient, and I'll give the sum. Okay, so and sum is, and I'll give some sum over here. In the similar way, I'll do it for 3, 2, 3, 4, and 5 and 6 and all that. Till I'll be doing this till so I'll be doing this till n. Okay, so whatever the user gives. So first I'll print this. So this is what you need to produce as an output. Okay, so this is what we'll be producing as an output. And after printing all the numbers, whether labels, whether they are deficient or abundant or perfect, finally what I'll be printing is I'll be printing like print the count. Okay, so count of deficient numbers in this particular range, like 1 to n, how many deficient numbers are there. In the similar way, how many abundant numbers are there, and then how many perfect numbers are there within this range. So this is the output that we need to produce. Okay, so I hope the output is also clear now.
Yes, ma'am.
Okay, so now let us get started. So the first thing that I need to do is I need to read in what is n here. So I'll be prompting the user to enter n. N should be a positive number. Um, So that all you can actually write it in your program, that if n is again less than 1 or whatever, you can just stop your program from execution and ask the user again to enter a number which is greater than 1. So that kind of checking for the inputs and all, you can do it. Okay. So here I'm asking the user to enter the value of n. So I said enter n. Okay, fine. And or enter the last number or the range or whatever, you can do it. Once I got this n, okay, you can do all that checking and all that. If n is less than, okay, so less than 1, so what we'll do is we'll say print, and then we'll put some error message saying that n should be greater than 1 and all that. Okay, and in the else part you can write the rest of the code. Okay, but I'm not doing that as of now. You can actually do that. And having understood that the user will be giving a number greater than 1, so first thing I'll be doing is I'll be printing 1. 1 is deficient. Okay, and the sum is 0. Okay, so this is initially I'll be writing for 1 because I don't need to calculate it specifically, turn a loop and calculate it. So for 1 I'm just writing it that way. And next I should now start calculating the sum of the divisors. So for that, what I'm doing is I'm taking each and every number. So for I in range, so what should be the range? The range will be from 2 comma n. But if I say n, the loop will turn only till n minus 1. So for that I'm saying n plus 1 over here, because if I give n to be 100, then I want 100 also to be included in the range. So that's why I said 2 comma n plus 1. Okay, so inside this, now I'll be calling a method, or else you can also write the code over here. So I'm calling a method which is get divisor. Okay, so get divisor sum or whatever. Okay, so get divisor sum. And so this method, into this method I'll be passing I, and it will take the value I, it will take the I, calculate the divisor sum and return it to t. Okay, so that's what this get divisor sum will do. After getting the divisor sum, now I'll be checking. So I didn't write the get divisor sum. We'll get into that module later. But as of now, say that I got the divisor sum. Okay, so what will I get from the divisor sum is this one. Okay, so say in place of I have passed 28. So then this method, this function will calculate this one. 1 plus 2 plus 4 plus 7 and 14, and whatever is the sum of these divisors, it will return it. So that return value is taken into t. Okay, so now I am checking on whether t is equal to I. Okay, so if t is equal to I, then it means that it is a perfect number. So I'll simply say print, and then I'll say I is a perfect number. Is a perfect number, and is a perfect number. But we also need the sum, right? Because the question is asking us to do that. What is along? See, print all perfect numbers along with its sum. So we need the sum also. So this is what you need to do with the case studies. Take each and every point, and everything need to be there in your program. Okay, so you should not be doing it partially, half and all that. Everything should be included. So here accordingly it's saying print all perfect numbers along with sum, with its sum. So where is this sum? The sum is in t, right? So I'll be just taking that. So is a perfect number, and sum is, and what is sum is t. So I'm just putting it that way. Okay, right. So if this if condition is false, then it will come to the else part. So here if t is greater than I, so then it's an abundant number, right? So that's what I'll do over here. So I'll take the same print statement and I'll change it. Okay, so then it is abundant number, and the sum is this one. And so we are having another else also. Okay, so three things, right? Perfect, abundant, and deficient. So for that, I'm using an elif over here, and then finally I'll give an else. If you want, you can also give an elif and put the condition, but there is no point in putting the condition because it will be less than, equal or less than or greater than. That's the only three cases we'll be having. So I'm not writing an elif over there, and this means that it is a deficient. Okay, right, deficient. Okay, so now that we have written the logic, now we are left out with the rest of the algorithm. What are the two things that we are left out? So the first thing is, like, I need to write the code for I need to write the code for get divisor sum, and the second thing that I need to do is I need to give the count. Okay, so these two things are left out now. Okay, right. I hope everybody understood this part of coding.
Yes, ma'am.
Yes or no?
Yes, ma'am.
Can I get two more confirmations from anyone in the class?
Yes, ma'am.
Hmm.
Ma'am.
Yes.
Yes, ma'am.
Yes. Fine. Okay, so now let us start writing these two things, add these two things into the code. Okay. So the first thing I need to do is, since this is a function and I need to write it before I call it, right? So the function need to be there before it. So I have to write this method before this. And after that, I'll come back to the count. Okay, now let me write the code for get divisor sum. So I'll be writing it before it itself. Because before I call it itself, I need to get the function. So how do you write a function? So I'll be having a keyword which is def keyword. And what is the name of the method? The name of the method is get divisor sum. So I'm just giving the name of the method here. It can be anything of your choice. Okay, fine. What it is taking? It is taking I into it, which is a number. So I'm just taking it into a variable which is num. And inside this, what I'm doing is here, like, just try to understand the logic. For example, so we'll take an example of 28 itself. 28, first we'll be checking whether 28 is divisible by 1 or not. And 1 is a divisor for all the numbers. So I don't need to specifically check whether 1 is dividing 28 or not. It's a proper divisor of 28 or not. Okay, so this is one point, keep in mind. And the next thing is I'm finding out the next divisor. Okay, how do I find out the next divisor? So I'll check whether each and every number, I'll check for each and every number. So 28 mod 2 I'll do, and then I'll say 28 mod 3, and then 28 mod 4, and 28 mod 5, and so on, and so on till 28 mod 27. Okay, so this is exactly what you need to do to find out the divisors. I don't need to find for one, okay, but according to the formula of the perfect number, I just need to stop. I'll not consider the number itself into this one, else the sum will be some greater than that itself. Okay. Anyways, so this is what I need to do. Another important point is, one, I'll not be considering it, and the next important point is, if it is equal to 0, okay, so then I'll say that it is a divisor. If it is not equal to 0, then I'll exclude it. Okay, so 28 mod 2 is 0, so 2 is the divisor. then I'll be checking for 3. Okay, so then I'll check for 4. 3 I don't get a 0, so I'm excluding it. For 4 I'll get a 0. Okay, so I'll include it, and because 4 sevens are 28, so this is again divisor. And 5 again I'll check, it's not equal to 0, so we'll exclude. And like this we got this 1, 2, 4, 7 and 14. If you can see that 4 I got, and then 7 I got, and then plus 14. So I don't need to check for 15, 16 and all that, because 14 twos are 28. Okay, now 15 twos will become more than 28. So from 15 onwards, there won't be any divisors for 28. This is another logic that we need to find out. Okay, because this is how you need to make your algorithms better. I can simply run my algorithm, my loop from 2 to 27. But that will become a very stupid algorithm, because there is no meaning in checking for whether 27 is a divisor of 28 or not. So it doesn't make any sense. Your algorithm I say that it is not at all a good algorithm. You can just dump it in the dustbin. Okay, your algorithm should be more optimized, and it should be more worth it. So for that, we are actually understanding the problem statement better. So here I don't need to continue further. Okay, so when I get like 14 twos are 28, I think the rest of the numbers I don't need to iterate to find out whether they are divisors of 28 or not. So I need to get half of 28 in the similar way, not only 28, the other numbers also. Whatever number I want to find out the divisors of it, I think after half of it, I don't think so. We need to find out whether it is a divisor of the number or not. Are these 2 points clear to my class?
Yes, ma'am.
Yes, ma'am.
Okay, so this is how you need to process a problem. Okay, so you should not straight away jump to writing the problem. I think you have seen me how I'm writing the programs. I'm not writing the program straight away. I'm understanding the problem statement very carefully. I'm writing an algorithm, and then I'm getting into the I'm writing the code. Okay, so this is what everyone need to do. So getting understanding these basic things, now I need to find out the half of the number. So for that, I'm taking a variable which is n. N is equal to, so I said math.ceil, and then inside this, what I'll do is I'll say math.sqrt, and then I'll pass the number into it. Okay, so I'll pass the number into it. So you know what is square root? I'll be getting the square root of a number, and after getting the square root, I'm sealing it. Seal means that it will be rounded off to the nearest higher number. So since I'm using math, I need to import that module in it. So that's why I'm saying import math. So I hope everybody understood this line, why I have written it. So then I need to find out the total, right? Total is nothing but the sum of all these numbers. So obviously every number will be having a divisor which is 1. So that's the reason why I'm not putting my total to be 0. I'll be putting my total to be 1, because 1 is all obviously there for every number. So that's why I have made it 1. See, we for making a variable, for initializing a variable also, we are thinking so much. This is what we need to do. That's why it is all about your mind, your logic, your strength in the programming language is shown in your programs. Okay, right. So I said total is equal to 1. Now I am taking the divisor. So initially the divisor is equal to 2. So as I already told you, like I'm excluding 1, and this divisor will start from 2 to till what? Till n minus 1, it should actually iterate from 2 to n minus 1, it should iterate. But as I already told you that till n minus 1, it doesn't make sense. So it need to iterate till half of the number. So which is taken into a number n. So it will iterate till half of the number which is n. Okay, so that's what we are doing over here. And straight away I'm getting into the loop now with the initialization and all that. So inside the loop, I'll be turning the divisor, so which will be less than n, and then I'm putting a colon over here, and then the while block started here, and I'll be checking whether it is dividing it or not. Okay, proper divisor or not. So num mod. So I have put I have taken the number into this num variable, right? So num mod and then divisor. Okay, so if it is equal to 0, so that's what we are going to check over here. So is equal to 0. If it is equal to 0, now what you need to do is you need to sum it up. That's it. Okay, so where to what you need to add? So you need to add it to total. So total is equal to total plus the divisor, right? Okay, so that's what you need to do over here. Or else you can also say total plus is equal to divisor. For you to understand, I am actually splitting it up and writing it like this. Okay, it's a compound assignment statement. So wherein you can also say total plus is equal to divisor. So another very important point that you need to observe here is, for example, let me take an example that you have number is equal to 6. Okay, so I'll be giving you in terms of the variables here. So num6 is passed here, okay, to find out whether it is a perfect number or not. So what is the value of total? So total is equal to 1. And then divisor, so I'm just giving you the tracing of it so that you will understand it better. So divisor is equal to 2. Okay, so these are the initialized variables that we have got. And now I need to initialize n. Okay, so what is n? N is equal to, so first the square root of the number happens. So square root of 6 is 2.44 bar something. And then math.ceil will make it near rounded off to the nearest highest number, which is 3. So n has become 3 now. Okay, so now how this while loop iterates? So what is the condition in the while loop? So the condition in the while loop is that divisor, which is 2 is less than n. Okay, so which is 3. And then what I'm doing, so this condition is true. So what happens is I'll enter into the loop, and then I'm finding out whether 6 mod 2 is equal to 0 or not. So this condition is true. Okay, so 2 is dividing 6, it's a proper divisor of it. Okay, so when it is true, what I'm doing now, I'm adding 2 to the total. So what happened, total value will be now is equal to 1 plus which is 2, right? So total has become 3 now. Okay, you can also go back, iterate like this, making your incrementing your divisor. You can say divisor is equal to divisor plus 1, and you can also put an less than or equal to symbol here and then iterate. Okay, so that's another method. Now what is the logic that I am adopting at this point is, when I said 6 mod 2 is equal to 0, 0 is the reminder, right? So this modulus symbol is actually will give me a reminder. Okay, so the quotient, I want to extract the quotient because the quotient will also is a proper divisor of this 6. Okay, so that is a very simple logic point that I'm extracting from this particular statement. Okay, so I am using the modular symbol to find out the divisor, but the quotient that I get also is a divisor of 6. So I don't need to turn the loop once again, because turning the loop is very costly. It will actually kill your time. It increases your time complexity. You can also do that over here, but we are trying to optimize it. So how do I get the quotient? I'll get the quotient by doing the floor division. So that's what I am doing over here. I hope everybody understood this. Is this clear or not?
Yes, ma'am.
Yes, ma'am.
So now I am trying to extract the, what I am trying to do, I am trying to extract the floor quotient by doing the floor division. So I said total is equal to, then again total plus, now what do you want? You want number, floor division, divisor. So what do I get here at this particular point? If 6 is there, 6 mod 2 is equal to, let me do it in this particular line. If 6 is the number, 6 mod 2, 6 mod 2, if it has given you a 0, then it means that 2 is a divisor, right? So what you're doing here, you said total is equal to, then what is total initially? It is 1, 1 plus, and then divisor is 2. So which has given you a value of 3. In the next statement, what I am doing is, if 2 is a divisor of 6 and which is generating a 0, meaning that 2 3s are 6, meaning that 3 2s are also 6. Okay, I am taking that 3, extracting the quotient by using this floor division operator. So T is equal to, total is equal to total, which is 3, plus and again a 3. Okay, so which is the quotient over here. So which has given me a 6. Okay, right. So with a single iteration of the while loop, what happens is the program will end for me. Okay, right. So I hope this is clear to everyone. Is it clear, girls?
Yes, ma'am.
Yes, ma'am.
Okay, so now what we'll do is we'll actually increment the divisor. So divisor is equal to divisor plus 1. Okay, right. So we are incrementing the divisor. And so after finding out, so what we need to do, here the method is returning something, and we are catching it in a variable t over here. So there should be a return statement here. And what should it return? What should it return? Num or n or divisor or total, or what it should return?
Total.
It should return total for me. Yes, good. Okay, so the total will be returned. Fine. So this is the program which actually will find out whether a given number is perfect or deficient or abundant. Okay, right. So let me first execute this program and then we'll try to add the count to it. So I'm removing this part. Okay, so this is your entire program to find out whether a given number is deficient or abundant or perfect in a particular range. Okay, so I'm saving this program, quitting from the editor. So let me execute this program. So this is how do you execute? So I say Python and then pr1.py. Okay, there is an indentation there. Okay, fine. I need to give. Okay, fine. Okay, I hope you can see the output. Are you able to look into the output or not?
Yes, ma'am.
Okay, so let me give 50. So you can see I got some results from 1 to 50, wherein 1 is deficient and some is 0, and then 2, then 3, 4, and then you can see 5. Okay, and you can see that 6 is a perfect number over here, and then you have one more perfect number which is given in your question. So which is 28 is a perfect number and sum is 28. Okay, so this is all regarding your perfect number. Now let us see get the count of it. Okay, so how do I get the count of it? I'll just get the count by putting a counter over here. So you can just have a counter which will actually count the number of occurrences. If this condition is true, it means that it is entering into this block, means that it is a perfect number. So I'll just take a counter. So take a counter. So the first counter will be for D. So D is equal to 1 because we already will represent the counter for the deficient number. So we already have put 1 over here. So I'm giving 1 here for it. For the abundant number, we haven't printed it. So A is equal to 0. And then for the perfect number, the counter is P. So P is equal to 0. So in here, what I am doing is I'll be counting it, okay, incrementing it. Whenever the control enters into this block, it means that it is a perfect number. So I'll just increment it. So P is equal to P plus 1. In the similar way, I'll also increment the counter. If T is greater than I, it means that's an abundant number. So A is equal to A plus 1. Okay, and likewise, we'll be doing it for increment the counter for D. D is equal to D plus 1. Okay, finally, after printing all the numbers, what I'll do is I'll have a print statement here. So in the print statement, we'll say, okay, so the number of deficient, the count of, okay, so we'll say the count of deficient numbers is, okay, and then we can simply give the count. So what it is D. Okay, if you want to mention the range also, you can also mention the range. The count of deficient numbers from 1, 2, and then close the single quotes here, put a comma, and you're reading it in N, right? So put it in N, and then you say is, and then like this. Okay, fine. So this is how you can do it if you want to print the range also. So if you want your output to be more readable and understandable to the user, you can also do it in that way. So this is representing P. So I just need to change here that it is perfect. Okay, perfect numbers, and this is abundant numbers. Okay, right. So this is what so let me run the program. Okay, so let me give it till 30. So you can see these are all the numbers, and you can see the counts at the end. Okay, so the count of deficient number from 1 to 30 is 23. Okay, 23 plus 5, which is 28, 28 plus 2, which is 30. Okay, so all the 30 numbers are here. Okay, and the perfect numbers are 6 and 28, right? So there are only 2 perfect numbers, and then we have 23 deficient numbers and 5 abundant numbers. So this is your case study 1. Okay, is the screen visible to you? Can you see the case study on classes, everyone?
Yes, ma'am.
Okay, so let us go through the question carefully, and then we'll start solving it after understanding the question. So before starting in coding, it's very important that we go through the question carefully. Understanding the problem statement is very, very important. So design a class. So here the concept is like you need to write a class, and the name of the class should be quadratic equation. So there are certain specific things that you need to follow, because case studies where each and everything that is mentioned need to be followed blindly. So here design a class named quadratic equation. So the name of the class should be quadratic equation. And what the class need to contain is that the class need to have private data fields A, B, C. Okay, because this is mentioned, your class need to have the private data fields that represents three coefficients. Okay, so A, B, C are the three coefficients, and what you need to do is they need to be the private data members. Okay, so they need to be private data fields. And what we need to do is there need to be a constructor, meaning that init method need to be there, which will actually initialize the values of A, B, and C. Okay, so this is a constructor for the arguments for A, B, and C. All the values of A, B, C it takes in and it initializes them. And then there are you need to give three get methods for A, B, C. The get method will display the value of A, and the other get method will display the value of B, and the other get method will display the value of C. Okay, and then what else you need to have? You need to have a method which is named get discriminant. Okay, so what need to be there in the discriminant is given here, and the discriminant will return the discriminant. Okay, right. And what this need to include? So the discriminant is b square minus 4ac. So b square b into b minus 4ac. So this is discriminant. So it need to return, take in the values of a, b, c, perform the operation on this particular expression, which is b square minus 4ac, and return the result. So that's one method. And the other method that the class need to have is get root 1 and get root 2. So these two will be returning the roots of the quadratic equation, where the formulas are also given for you, where the root 1 will be equal to minus b plus square root of b square minus 4ac by 2a, and you know this formula. Okay, so minus b plus or minus. So here plus is considered to be one root, and minus is considered to be another root. So get root 1 need to return this plus root here, and get root 2 need to return this minus root over here. So this is another method that your class quadratic equation need to have. And then these methods are useful only if the discriminant is non-negative. So these conditions you need to check. Okay, and let these methods return 0 if the discriminant is negative. So this is the condition. So if the discriminant is negative, then the method should return as 0. You should write it in such a manner. So now write a test program that prompts the user to enter values for A, B, C and display the results based on the discriminant. So this is your question. Okay, I hope the question is clear. Is the question clear or not?
Yes, ma'am.
Okay, let me get some more confirmations from other girls other than the voices I regularly hear.
Yes, ma'am.
Yes.
Okay, now let us start working towards solving this particular problem. So can you see the terminal?
No, ma'am.
Okay. Now is the terminal visible?
Yes, ma'am.
Yes, ma'am.
Okay, I'm taking a class which is qe.py. Okay, so this is my file name, qe.py. This is my file name. So let us take each and every part of the problem. So let me copy the question case study to your editor, so that we'll process each and everything. So the first thing that the question states is that you need to create a class which is called as quadratic equation. So the first thing I'm doing is I'm giving the class keyword, and then the name of the class is quadratic equation. So I just made the name of the class to be that with that name, equation. Okay, so there is no, well, fine. I was actually doing working out with the Java manual from past 2 days. Um, in while working out in Java, I am not giving the I mean system.out.println and the semicolons in the Java manual, and coming over here I started giving a open bracket and close bracket. Okay, fine. So learning too many programming languages is again a confusion. Anyway, fine. So I do have this colon over here. So this is how the syntax looks like. 3, 4. Okay, so I gave an indentation over here, and let us move on to the rest of the part. So here you need to calculate something, right? Square root and all that you have. So you might be needing the math module. So I'm saying import math. Okay, so this is what I am doing. Whenever I need the square root from the math module, I'll work on it. So I'm making it a handy thing for me. I'm importing into my program and keeping it aside. So the rest of the part is like you need to have a constructor. So the constructor says that a constructor for the arguments A, B, and C. So I'm writing the init method. So init method, you know what is an init method. I needn't explain you that. Getting back to the basics of the classes and objects. So it's an init. It's a constructor. So I said self, comma A, comma B, comma C. Okay, fine. Now what I need to do inside this init method is I need to initialize the variables. But here these are not normal variables, as the question asks us to make these variables as private data fields. So how do you make a data member private? Is that
Double under.
we'll be putting a double underscore in the beginning. So I said self dot underscore underscore A is equal to A. Okay, so this will make the variables as private variables, wherein access of these variables outside the class is not permissible. Okay, so that is what the access modifier private says us. So this is how I'm doing it. So I have taken a class which is quadratic equation. I might be needing the square root method from the math module. So I have imported the math module and kept it handy. And then I have written the constructor, and the constructor will be taking, so the constructor for arguments A, B, and C. So I have taken the 3 arguments A, B, C. And then I made ABC as private data fields. These 3 will represent the 3 coefficients. Okay. So in ax square plus bx plus c. So this is one of the examples of the quadratic equation. So A, B, C here are the coefficients. Okay, right. And so we need to have 3 get methods for A, B, C. So let us start writing that. Okay, so these 2 parts are over. Like we have a private data fields and all that. I'm just removing them because we have done it. Next, we'll be writing the 3 get methods for A, B, and C. So let us write that. So which are methods, right? So 3 get methods. So again, I need to have, they didn't mention the question, didn't mention on what kind of methods they are. So I'm just making them as public methods. Okay, so get A. So 3 get methods for retrieving the values of A, B, and C, right? So that's why I'm making my methods to be specific which variable it is printing. So I'm saying get A, which will actually return the value of A for me. Okay, right. So it should return the A, right? So that's why I am. So return. So what it need to return? It need to return the variable A. So self dot underscore underscore A. Okay. So in the same manner, I will also write the get method for B and also the get method for C. Okay, fine. So let me change the name of this method, which will be returning B and which will be returning C over here. And this should be B and this should be C. Okay, so we have completed writing this get method. So I'm just taking it off. So what else we have? We have a method named get discriminant that returns the discriminant, which is b square minus 4ac. So let us write the discriminant method. So that the method is written in the method is written in the similar way like how we are writing, so which is def. And what is the name of the method? So here it is specifically mentioned that the name of the method should be get discriminant. So I'm just copying the name of the method over here, which will be having a self inside. And so what this method need to do, this method need to return something. What it need to return? So return the discriminant, which is b square minus 4ac. So let us calculate b square minus 4ac. So which is self dot underscore underscore b. So power, right, square. So I'm giving this exponentiation operator over here, minus 4ac. Okay, 4 into, so this is into is a operator which will do the multiplication of the numbers, dot underscore underscore a, and then into, and then 4ac, right, into, and then self dot underscore underscore c. Okay, so this will return the discriminant for us. Okay, so this part is also over. So we have written the method. Now what is left out for us? So we are left out with the methods named getRoot1 and getRoot2 for returning the two roots of the equation using the formulas. So we need to write two more methods here. So the two methods will be, the name of the methods are getRoot1 and getRoot2. So let me write those methods here. So which is def, and the name of the method is getRoot1. Okay, so which will be taking self in it, and so we'll be calculating the roots. Okay, to return the roots, there is again a condition over here that these methods are useful only if the discriminant is non-negative. Let these methods return 0 if the discriminant is negative. So that condition we need to check over here before returning the roots. So I'm checking the condition. So I'm saying if self dot get a discriminant. So this is the name of the method. So I'm calling the method over here. Okay, so get a discriminant, and if this method is less than 0, means that it is negative. Okay, so if discriminant is negative, so then what I need to do? So there should be a colon. So this is if block, and this is the function indentation, and this is the if indentation, right? 1, 2, 3, and 4. Okay, so here I need to return a 0. So this is what we are doing, because it's specifically mentioned here that these methods are useful only if the discriminant is non-negative, and let these methods return 0 if the discriminant is negative. Okay, so that's what we are doing. If this if part becomes false, meaning that discriminant is not negative value, then you calculate and return the root. Okay, so what is the root? Okay, so I'm saying return. So the formula minus b and all that. Okay, so minus b, so minus self dot underscore underscore b plus, so what is the formula? Root1 is formula is plus, and then let me separate it. Then I have this math dot sqrt, and then I need to calculate this b square minus 4ac. I won't be calculating b square minus 4ac. I'll be calling this get discriminant method over here on self. So self dot get discriminant. So I'm calling this method here. Okay, so which will work on this discriminant, and then it's a function. So I just need to put that and put another bracket over here. Okay, so this is for the method, and this is for the square root, and okay, fine. Okay, fine. And then divided by 2 into a, right? So just put it in the brackets and write that. 2 into, so self dot underscore underscore a. Okay, that's it. So this is regarding root 1. So now let us write root 2. So I'm just copying the same function. Girls, are you following me?
Yes, ma'am.
Okay, so this is this is get root 2. Okay, so what I should do here, I just need to change it to minus because it's minus b minus right. So I just need to change it to minus. So again, you need to consider for root 2 also you need to consider this condition that if discriminant is negative, then you need to return a 0. Okay, fine. So we have written this root 1 and root 2, and also we have written this conditions over here. So all these parts are over. Now what we need to look into? So we need to write a test program. Okay, so to check whether everything is working fine or not. That prompts the user to enter values A, B, C. So let me start doing that. To enter the values of A, B, and C, first thing is I need to create the object of the class and pass the values of A, B, C into it. So I need to first read in the values from the user and then create an object. So first thing is I'll read in the values of coefficients of A, B, C, and D, A, B, C from the user. So input, enter coefficient A. Okay, so I'm trying to be more specific. Okay, and then this is regarding B and C. Okay, so this is B and this is C, and then so B and then C. Okay, right. So I have asked the user to enter these three coefficients. So the user will be giving the three coefficients. Once the three coefficients are ready, then we'll be creating an object. So I said obj is equal to, so the name of the class is quadratic equation. So I just need to write the name of the class followed by parenthesis, which will in turn call the constructor for me. I need to pass in the coefficients A, B, C into this particular constructor. So automatically init method is called and the private variables A, B, and C are created. Okay, so now let us check these three methods, which is get A, get B, and get C, whether they're working or not. Okay, I'll call it through the object print, and then I said get A, and I'm putting a colon over here, semicolon over here, and then I said obj dot get A. Okay, if I directly access the variables, I will not be able to do it, but through the method I can do it. So to access the values of B, and this is get C. Okay, right. So obj dot, what's the name of the method? It is B, right? And this is get C. Okay, so let me run this program till here and check on whether this is working fine or not. So what's the name of the file? The name of the file is QE. So let me get back to the terminal. So can you see the terminal, Ma?
Yes, ma'am.
Yes. Okay, so Python 3 QE.py. Okay, I didn't put that in comments. Okay, fine. Okay, so all these are comments.
Ma'am, self. In get discriminant method,
Ah,
self, ma'am.
what?
-4 into self dot underscore underscore C, ma'am.
Okay, okay. It should be L is there. Okay. Okay. Okay, I didn't give a column.
Single code.
Okay, so let us just read into the values of A, B, and C and see whether it is working fine or not. So 1, 2, and 1. So you can see that the methods get A, B, C are working good for us. Okay. So let me get back to your program. So this is regarding how you're accessing the private methods through the get methods. Okay, fine. So what we need to do now, we need to access, okay, calculate the discriminant and call the discriminant method and all that. So let me do that now. So I'll come here. Okay, I'm checking on it. Okay, if so, I'm calling the discriminant. So obj dot. So obj dot get discriminant. Okay, let me get this method. Okay, so if it is greater than 0, so the same old story. Okay, so what you have written in what you will be writing for it is real and different roots and all that you write. Okay, so all that I needn't tell. I am here to tell you the programming part. So this is all in your mathematics. So if it is greater than 0, then we are saying we are calculating the discriminant. Okay, so once you get the written value, what is discriminant is b square minus 4ac, right? So that's what you are returning from the discriminant method. Okay, so this is what will be returned from the get discriminant method. So once you get the value, and if it is greater than 0, then you are saying that the roots are real and different. You can also simply leave it off like this. Okay, so but according to our case study, we need to print the roots also. So that's why I'm actually maybe in your first year, I don't know whether you have worked it out in your C programming and have displayed the roots or not, but here specifically in our case studies, the case study is it is mentioned in the question that we need to actually get the roots and print it on the screen for the user. So what's the name of the method? The name of the method is get root 1. So I'm just calling that method in the similar way, so which will return the root 1 for me, and in the same way I'll write it for the second root. Root 2 is equal to get root 2. This is the name of the method. Okay, well, fine. So if the discriminant is greater than 0, we are doing that. Elif, so if the discriminant is equal to 0, then what you need to do it. Okay, so I'm taking the same method here by changing the relational operator here. So I need to put a colon also here. Okay, fine. Okay, put a colon here. The syntax rules of Python. Okay, fine. Elif obj dot get discriminant. If it is equal to 0, then I'll just print saying the roots are real and same. Okay, let me. Okay, fine. The roots are okay, real and same roots. Okay, let me write that. Okay, and you just need to print the discriminant. If you just I can simply calculate it, because this is the scope of this ABC variables are throughout this program, so I can just directly access them, or else just leave it off saying real and same roots, or else you can also do the calculation and show the roots. Okay, so 2 into a, I'm not accessing it through the get methods and all that. I'm just doing the direct calculation and showing it. Okay, so else it means okay, so greater than equal to, so it means that it is less than. So now I'm saying print the roots are complex. Okay, roots are complex. Well, fine. So that's the end of the program. So let us see everything is included or not. So we are writing a test program. The name of the test program is qe.py, and then prompt the user to enter the values of ABC, which we already have done, and display the results based on the discriminant. Okay, so based on the discriminant, if it is greater, less, or equal, so based on that, we are printing the certain values. Let me save this and let us check whether for various values of A, B, and C, let us check the answers. Okay. So you got an answer that real and same roots. You can check for whatever you want. Okay. But you need to debug for all the cases. Okay. In my manual, I have given all the 3 cases for you so that that's my way of debugging. Whenever I write programs, I always check all the paths, whether all the paths are correct or not. So I don't stop it with one result. I'll check it for all the results. So one I got real and same roots I got. Let me check for real and different roots. For that, let me give some values over here. So 4, 5, and okay, -1. Okay, I got real and different roots. And also the roots are printed here. You can use your format method to actually format the roots and print only the 2 values or 3 values after the decimal point. Let me run it one more time and see for the complex numbers. So I gave 5 for this, -1, and then 3. So you can see that roots are complex. So wherein all the 3 paths of execution are working fine for me. And this is how I addressed the case study. Is the program clear?
Yes, ma'am.